So, hi everyone. If you are facing any problems like audio and video, please tell me in the comments. And then we will start with the stacks data structure. Just say hi in the comments and I will be able to know that everything is fine, right? Because I do not want to start with bad audio quality or anything like that. Bro, why first class itself is about stacks, why not about arrays? Well, the reason is the arrays come inside the programming language, right? For example, if you're learning, I've already told you that it is the eligibility criteria that you should know C++ and arrays come in C++, right? So it simply means that we are not going to pick that, but when we are covering stacks we are going to use arrays. So in that case you don't need to worry about. We will uh, discuss about arrays only because we are going to implement stacks using arrays data structure, right? We will implement stacks using arrays. Now one good thing about today's live class is that we are going to implement stacks in all the programming languages. C++, I have Python here. First we will implement it in Python, then I have already set up the C++, right? So I will create the program in one programming language and I will just show you how it is implemented in other programming languages. We will discuss them line by line, right? We will discuss this whole program line by line. And similarly we are also going to do it in Java also, right? So basically first of all we will start with the introduction to the data structures, right? We're going to start with the introduction to data structures now. First of all, I want to introduce what are data structures. I will take just 2-3 minutes to explain you about what exactly data structures are and what is the significance of studying data structures. And then I will give you the theory part of the stacks. All right, so let's start with the introduction to the data structures part. Right, so data structures is basically what we're trying to do is we're trying to make different structures of data, right? For example, let's say I have these three numbers, right? 1, 2 and 3. These are this is basically a data can be a string, it can be a character or something like that. So different data structures are there. For example, if we consider linked list, we can just connect them, all these data structures like this. When we are considering stacks, we can actually show 1, 2 and 3. For binary trees we will have different structure, and similarly for other data structures also. So basically what is the significance of having so many data structures, right? Why we can perform insertion in this data structure also, in this one also, and this one also. Then why do we need different data structures? Well, the reason is that they have different applications, they have different time and space complexities. For different, I'm going to write here time and space complexities, which we will also discuss in case of stacks and everything else. So now you can see that in all these data structures, we will start with the stacks, which is implemented using arrays. In Python, we have list. So I'm just going to write here list as well. We are going to use list in Python to implement stacks. So let's start with our first data structure, which is basically a stack, right? So what we are trying to do is a FIFO structure, right? So stack follows a very basic restriction or the FIFO rule, which is the first in first out, right? All these data structures, linked lists, stacks, binary trees, heaps, and all these data structures, they have some restriction, and these are the basically structures, and that is the main reason why performing operations like insertion or deletion or even searching inside of a data structure is different in all these cases, right? So first in first out is basically, it basically means that the first element to go inside of this data structure is going to become the last, sorry, it should be last out, right? FILO. I just did a mistake here. So this is a FILO data structure, first in last out. So basically, to avoid confusion, let me show you how a data is inserted inside of a stack data structure. So we have 1, 2 and 3. So let's say we want to insert 1 inside of the stack, right? So we will push 1 inside of the stack like this. Now if I want to insert 2, I can insert 2 here like this, and similarly for other data I can do it like this. See that this is the top of the stack. When the stack was initially null, right? And now the stack is updated to, now this top is updated to this value, right? So basically what I'm going to do is I'm going to just explain you, and if you have any doubts you can ask it in the comments. I will read them. Explanation for any type of thing, like in stacks you want to study something else, some applications, I will tell you right here, right? So initially our stack is empty, right? Our initial state of the stack is that the stack is empty, right? So the value of top will be equal to -1, right? So if the value of top is equals to -1, we can actually use this test case, right? It can be used as a test case to represent whether the stack is empty or not. Inserted in this stack, right? 1 is inserted here. Now we will update this top to not point to the -1 but to point to this structure 1, and similarly we can keep updating the value of top as we are trying to insert some more elements inside of this stack. Now we are going to use arrays, right? We are going to use arrays to implement this type of a data structure. And let's say I will construct an array here, 1, 2, 3 and 4. Let's say there are 4 elements. We know that in arrays indexing starts from 0. So 0, 1, 2, 3 and 4. Now you can see that if I want to insert data 1, right? So initially top is pointing to -1 because our stack or the array is empty. Now I want to insert. Now remember that insertion in stack is known as push, right? We call it as a push operation because we are trying to push elements into the stack. Now if I push 1 inside of the stack, and then I will update the value of top to from -1 to 0, right? So I will keep incrementing the value of top. Again, if I want to perform a push operation, I will insert 2 here, and again I will update the value of top equals to, now top is actually pointing to this position, which is 2. Similarly for 3 also we will do the same. We will keep incrementing the value of a stack. Is basically, in very simple words, you can see that if you have some books, right, you can stack them up like this. So you can see that, let's say this is book 1, this is book 2 and this is book 3. So you are actually stacking them up, right, in this way. Now the important part is the pop operation, right? Pop operation is also known as, is just the delete operation, right? Now let's suppose you want to delete some element out of this stack. Now here comes the restriction, which is the FILO restriction, which is the first in last out restriction, right? So let's say you want to delete or you want to pop an element out of this stack. So let's say you want to delete pop 2, right? I want to delete 2 from this stack. So I cannot do this directly, right? That goes inside of this stack. This is a very important line. The first element that goes inside of the stack is going to become the last element to come out of the stack, right? So you can see that first 1 is inserted, then 2 is inserted, then 3 is inserted. So you can see 1 is inserted first, so it is going to become the last element to get popped out of this stack. So if someone wants to remove 2, he will first have to remove 3, right? Now simply you can see it from this diagram also. Let's say you have 3 books, 1, 2 and 3. If you want to remove this middle book, which is book number 2, you will first have to remove 3. That is the only restriction of the stack. You cannot directly remove it. You will first have to delete or remove 3, right? Remove 3 and then you can remove 2. Then only you can remove 2, right? So whenever you are trying to pop out, use the pop operation inside of the stack, what you are going to do is, first, let's say this is the condition of the stack, 1, 2 and 3 is inserted, and now let's say you call the pop function, right? This pop function will remove 3 first, right? It will automatically remove 3. Now how can we remove 3 programmatically? How we can do this, how we can achieve this using the programming, right? Now what we will do is, you can see this is the top position of the stack. What we will simply do is, we will simply decrement the value of top by 1, right? So I will just decrement the value of top by 1. Now you can see that top is equals to 1 now. So now since the top is pointing to 1, this is the top of the stack. So now this is our whole stack. So 3 is popped out, right? Again, if you will call the pop function, let's say you are calling this pop function again, it will remove. Now you can remove 2. And remember, whenever we are trying to remove any element, we are just going to decrement the value of top by 1, right? So now it will become 0. Now the top of the stack is at 0, so only 1 is there inside of the stack. So this is the main idea behind the stack data structure, which is this restriction, right? So you will have to first push the elements, and if you want to remove any element, you will first have to remove the elements which were inserted in the last, right? So you will have to keep removing the elements in this fashion, which is the phyllo. Now what using this type of a data structure, why are we when we want to delete an element in linked list, we can simply remove it by reaching the index and we can remove it. Even in the binary trees, we can just go and we can delete a particular element, but only the stack is the only data structure where you cannot remove element 2 directly from this position. The reason is that there are some applications of this type of data. Discuss the few applications and then we will quickly move to the programming part, where we will program this whole data structure. We will implement the push function, we will implement the pop function, and we will also implement another function, which is the display function, which will display the contents of the whole stack. The first application is to get the least recently used element, right? To get the least recently used element. Now you can see that out of these 3 elements, 1, 2 and 3, now let's say I want to find out which element is least recently used, right? So let's say 1, 2 and 3 are now 3 different processes in a computer system, right? So let's say 1 is some process of creating a file, right? Let's say there is a process in the CPU, which a CPU is performing, which is to create a file, right? Let's say the second process is of opening some app, right? Open some app. Then the third one is of something like, let's say, deleting a file, right? So let's say these are the three different processes in a computer system, and we now store them in the form of a stack, right? So first, creating file is inserted inside the stack, then open app is inserted, and then 3. So now if we want to see which of these processes was initially inserted at first, then we can easily get it by using the pop function. We will continue the pop function until and unless the value of top becomes equals to -1, and then we can get the least recently used item, right? Application is also the recently used item, right? Recently used or recently added item, right? So one major application which you have also seen in real life, I'm going to discuss it now. Let's say you know that you have different apps on your smartphone. Now you open, let's say, 3 or 4 apps. You open them in some order, and whenever you go to the recent apps, right, there is a recent apps section inside your phone. When you open that up, you can see all the recent apps that are there, right? You can see all the recent apps that are there. Now if I want to find out what was the recently added or recently used, I can use this stack data structure. And Android basically uses this stack data structure to store different applications, and in that order we can actually retain when the element was added. Now if we will perform deletion at any position, then we will not be able to get the least or the recently used element, right? So this is a major usage. Even I have used in Android development also, right? In Android app making I have used it. So in these live sessions, I will also discuss some real life applications where I have implemented these data structures, where I have seen these data structures, and I will also ask you questions in between, and you can answer it in the chat also, right? So in Android application also I've used it to get the recent activities that are there inside the app. Now since most of the people have not done Android app development, if you have done, you might have seen this stacks are used there, right? So now let's move on to the main part. I hope you have understood this push pop operation and the applications. Before moving on to the programming part, which is in Python, C++, and Java, we'll do them in all. If you have any doubt related to this, you can answer, you can ask it in the comments here. I will reply to everything here, right? So I'm pausing here. If you have any doubts, you can ask it in the live chat section, and I will just answer your questions. Okay, so it looks like that not much people have joined this live session, and if in the future I see that more people are not coming, I will have to just stop this and I will keep recording the videos as I usually do. Only one viewer is there. Okay, so no problem, I will start with the Python programming, right? So let's implement the stack data structures in Python. In Python, we do not use arrays, we use linked list, right? Sorry, list. List data is there, which we are going to use. So first of all, I will create a list. I hope that you have done basics of Python, which we will use. Now implementing stacks in Python is very easy, right? Because we do not need to use any third-party libraries. The list structure the list data type, you can say, it offers two important functions, which is the dot append function and dot pop function, which basically are directly, we can directly use, right? So let's try to this is the stack. Initially you can see it is empty, right? So now we do not have the headache of actually using the top variable. Here we can directly use the append function. So what I'm going to do is I'm going to use the append function, and let's say I want to add some data to this stack, right? So now dot append function is basically used to push the data inside of this stack, and it will follow the FIFO rule, which is first in last out, right? So let's try to add some more elements, right? If you have your IDE ready, you can also program with me. That way you will understand it better. So stack dot append, let's add one more element, which is ABC, right? So these are the three elements that we have appended. Let's take a look at what is the condition of our stack now. All right, so here I've just returned this. Now you can see the stack, the condition of the stack is A, B and C. So we have appended A, B and C in this order. A is inserted, B is inserted, C is inserted. So this is our stack. Now let's say I want to remove B from this stack, right? So in order to do so, I will first have to remove C because it is the last element of the stack, and then only I can remove B, right? So here I'm just going to write comment removing the elements, right? Removing elements, or let's say removing element 2. For that we can use a function which is the pop function, right? Now after doing this, let's see what is the condition of the stack, right? Just if you're using Jupyter Notebook, you can just press Control Enter to run this program. So now you can see when I have used the pop operation, it has popped out the last element from the stack, right? In Python, we do not have much problem. We can easily do this, but in programming languages like C++ and Java, we have a different approach. So even if you are a Python programmer, and you can actually take a look at C++ or Java program also, right? So now let's say I again call the pop function, which is the stack dot pop function, right? Let me just call the pop function. I will press Control Enter. Now you can see after calling pop function twice, B is removed, right? So it means that A is the least recently used, right? So it was added first. So now the this one is the least recently used item. In this manner, we can just perform insertion and push and pop inside of the structure. For displaying, we can use print stack, right? So if you want to, if you're interested in knowing, you can use the help function, help stack dot append, right? Just write this. If you will press Control Enter, it just write this dot append. Now you can see the help related to this built-in function. It is a built-in function. We are not using any third-party libraries. In C++ and Java also, we will use the basic built-in functionality of the compiler, right? So you can see it says append. It is a method of instance of built-ins.list, and it appends object to the end of the list. End of the list is the basic you can say the rule of the stacks, right? Similarly, if you want help, you want to understand what is the use of pop function, you can do that, right? So it removes and returns the element at index, right? So if I just want to see what element has been popped out, what I can simply do is I can just write print stack pop. So it also returns the item at where it will remove it, right? So I'm going to use print twice and control enter. Now you can see C is removed and then B is removed. So this way you can also check which item is removed. So if you will call the pop function in the starting of the for the first time, if you will call, you will get the recently added item, which is C, right? So in this manner we can implement this stack data structure. In the next series, in the next tutorial, which will be the live video tomorrow, we will implement the linked list data structure, and it is a very important tutorial because there are no we are not going to use any functions like that in that. So we will create classes and objects. So now we are going to implement the same data structure, which is the stack, in C++, and side by side we will also do it in Java also, right? So this is C++ and Java, right? So if you are actually programming with me, you can just the first task is to create this main function, right? So you can create this main function. In this main function, we are actually creating an object of the class stack, right? So let me just zoom in so that you can see it clearly, right? So you can see I have created an instance of the class stack. We will create the class stack above, but first create this driver program, right? We will create three functions in this class. Let me show you the class. This is the class stack, right? So before writing the main function, first create a class stack, right? We will create a class stack, which is here. Now in this class stack, we have a private member, which is top, and this member is basically used to access the element at the top of the stack because we are only interested in that, right? In the public section, we have the size of the stack, and here we have a constructor. So whenever we create an object of this class, we know that the stack is empty, so this constructor will assign the value of top equals to -1. So in the future, if we want to check whether the stack is empty or not, we can use the value of top, right? So now we have some functions here. These are very important functions. The first function is the push function, which returns a value bool means true or false, and it takes integer item, right? We are just pushing integer items, so int x. Similarly, we have a pop function. The pop function does not take any elements because it simply removes the element from the last position, right? So we do not need to put any element inside here. Int, right? It means that it is going to return the item it has popped out. That's why the return type is int. Similarly, let's don't focus on the speak function. There is empty function which returns true or false, and it basically is used to check whether the stack is empty or it is overflowing, right? So I will have to explain this one very important thing, right? Very important thing. There are two test cases of, or I should say two cases inside of a stack. It is a very important point. The first condition is known as stack underflow, right? Stack underflow. And the second condition is known as stack overflow. These are the two important conditions to consider when you are trying to insert elements or delete elements from the stack, right? So when you are trying to insert an element in a stack, there are two conditions. Stack overflow means that now the stack is full, right? Stack is full and no more elements can be inserted inside of this stack. So in that condition, we will return that the stack overflow has occurred. The size of the stack which was decided initially, now it has reached its limit, and now no more elements can be pushed inside of the stack. The second condition is stack underflow, which means that the stack is empty, right? If the stack is empty and we try to call the pop function, we will return this value stack underflow, which means that the stack is already empty. You cannot do the pop operation. These are two very important conditions to consider when we are creating the stack data structure, right? So in C++, you can see here we have these functions, right? We will define these functions separately, but you can see here we have created an instance, or you can say an object of this class, which is the stack class, right? This is the object of the stack class. And now we are calling the push function with elements 10, 20 and 30. And then we will call the pop function, and we are going to use cout to display the element that has been popped, right? Now let's see the definition of before seeing the definition of this push function and the pop function here, you can do this similarly in Java also, right? In Java also you can do this. The first thing you need to do is you will have to create your driver code, right? Class thinkxtext is the name of the class it is the name of the Java file. Create the main function, create the object of the stack class, right? If you're programming in Java, create the object of this class, and all the functions push, pop, we are going to do the same, right? We will call these we will call the push function 3 times by inserting the elements 1, 2 and 3, and then finally we will call the stack pop operation, which will pop the element out, and then we will also show the status of the stack, right, or the elements of the stack. And here you can see the definition of the whole stack class. We are maintaining again a top variable, right? Top variable is there, constructor is there, top is equals to -1, which basically represents that initially the stack is empty. And you can see here we will create a stack with a maximum size, right? You can see max is the static final integer equal to 1000. Now you can see max is static here. It has the value 1000, and if you will see the C++ program, we also in the public section we have created a maximum size of the stack, right? This is the stack, and again you can see here we are using this preprocessor directory, which is the define directive, and max is equals to 1000, right? So what is the significance of this define and static, right? We will have to also understand it. So basically define and static, they have very similar functioning. So I will just do it here, right? So we have define directory and a static directory, sorry, just a static keyword in Java. Basically we are trying to assign max equals to 1000 as the size of the array or the stack, right? So a max. So why we are doing this, why are we using static and define preprocessor, is the reason is that they are used to allocate this max equals to 100 at the runtime, not the compile time, right? So it will basically assign it in the runtime, right? So okay, I will just do it here. These are the max equals to 1000 is basically going to assign the size of the array at the runtime, right? So the program is basically first compiled and then it is in the runtime, and we are assigning the size of the stack at the runtime. So now the CPU can use it, right? So now let's move on to the implementation of push function. right? We will consider push function first, and then we will consider pop function. They are very simple to implement. You're using C++ or Java, it's the same, right? First of all, this will return a boolean value, and we are using this visibility mode, and this is the implementation. We are passing the integer x. So whenever we will call this function, you can see in the main function I am actually trying to call this, right? You can see I'm calling this. So 10 is passed to this function. In the push function, you can see the 10 is passed as x. The first test case is this one, which is the which when we are trying to insert some element inside of the stack, we will have to first show. Okay, so we have a question: what's the difference in allocating the memory in runtime and compile time? Yeah, that's a good question. I will answer it. uh, First I will just display, I will tell you what this is, and then we will start with that question also. I will keep that in mind. So first of all, we have the stack overflow condition, right? In the stack overflow condition, we know that push operation cannot perform because the stack is already at its max position, right? So this test case says that if the top of the stack has a value which is greater than equal to max minus 1. Why max minus 1? Because we know that the indexing inside an array starts from 0, right? So it will be 0 till 999. So that's why we are writing max minus 1. So if the value of top is equals to, or if it is greater than this value, it means that we cannot insert anything inside of the stack, and it is a condition of stack overflow, and hence we will return false, that because we cannot push any element inside of this stack. Else we are going to return true, right? Because we can now push. Now consider these two lines, right? In this first line, this is a very important line. What we are trying to do is we are trying to push an element into the stack. For that, what we will do is we have the value of top, right? So we will increment the value of top, as I have already told you here, right? Here you can see that I've already told you this. Here you can see we are trying to do the stack underflow, and here we are trying to decrement the value in the pop function. In case of push, you can see I'm trying to increase the value from -1 to 0 to 1, right? So first we will have to increase the value of top, and then we are inserting the value, right? So this is an important point, and this is the main reason why we are writing plus plus top. All right, so here we will first increment the value of top by 1, and then at that position we will assign a of top equals to x, right? So the element x which we are trying to push into the stack will get stored at this position inside of the stack, and then we will just display that it is pushed inside of the stack. Similarly, you can do it in Java also, right? It's very simple. Here you can see this is the push function. First, we will check the condition. If the top is greater than or equal to max minus 1, again we will do the same. Else, you can see the same thing is there. We will first increment the value of top because we want to push an element, and then we are going to assign the element at that particular position. And then we will say that the element x is pushed into the stack. Now let's come to the pop function, which is the last function we are going to discuss, right? First of all, if top is less than 0, right? So top can, if top is any negative number, right, which is -1 or something like that, in that case we know that this stack is empty, right? If the stack is empty, we cannot pop out of the stack, right? So I will simply write that this is a condition of stack overflow, and I'm simply going to return 0. Else what we are going to do is, you can see we are just going to write int x equals to a and top minus minus. This is a very important line here, and then we are going to return x, right? So now you can see here we have a top minus minus. What is the meaning of top minus minus? Top minus minus means first we will use the value of top, right? And then we are going to decrement it, right? I will show you a simple difference among this. I will just close this and open a new workbook. All right. Right. So let's try to understand this thing. What is the meaning of plus plus top and top minus minus? Because in Java and in C++ we are going to use both of them, right? So top plus plus means, right, if I'm writing a of plus plus top, now let's assume that the value of top equals to 1 initially, right? We are just assuming this just to understand this concept. So if top is equals to 1, what I'm going to do is I will first increment, right? Here in this case we will first increment. If it is minus minus top, then we are going to decrement this value, right? So top 1 we will increment, right? After incrementing, the value of top becomes 2, right? So now this is similar to a of 2, right? Now let's say this is top plus plus, right? So it will be similar. Now in this case, let's study this top plus plus. Now let's say initially the value of top is equals to 1. Top plus plus means, let's say I'm writing here plus plus top, right? Sorry, it should be top plus plus. If it is top plus plus, we will use the value first, right? First increment, then use, right? This is actually related to plus plus top. In case of top plus plus, we are going to do the opposite, use and then increment, right? Or decrement if it is minus minus. So the top is equals to 1 initially, so we will use a of 1, and then we are going to decrease the value of top by 1, right? So now top will be equal to 0. Sorry, it is top plus plus, so accordingly I will write top equals to 2. Now if in the next line I try to write a of top, it will mean a of 2. This is the main difference between these two, right? These two are very important steps. So that is what we are trying to apply here. Here you can see, first we decrement the value of top, because in the pop operation we want to decrement the value of top, and then after decrementing we can say, right, it will first, it is top minus minus, so top will remain same, and after we will use it, it will decrement by 1, right? So why we are writing top minus minus? Because we are trying to fetch the element that we are trying to pop out from this stack, right? So if top equals to let's say if top is 1, so first we will say a of 1, because that is the element that we want to pop out, right? Which we will store in x and we will return x. And you can see this pop function has a return type integer, so that is the main reason why first we are using it, and after that we will decrement, the value of top will be decremented. After it is decremented, the stack will remove the element, right? And similarly in C++ also we are going to do the same thing. We are going to check whether top is less than 0, which means it is the condition of stack underflow, and then we are going to again do the same. We are going to return the value of x, right? So if I will run this program, let's run it in C++. Okay, so let's try it in Java first because it is not. So you can see here, first 1 is pushed into the stack, then 2 is pushed into the stack. So whenever we push an element, we increment the value of top and then we insert. Now 3 is pushed into the stack. Now we are popping 3, right? 3 is popped. If I will not use top minus minus, it will display 2 here, right? That's why I'm trying to use top minus minus, because it will fetch the last element and it will return that element, which is 3. Now you can see the value of top is decremented. So here you can see 3 is popped. Now at position 0 we have 1, at position 1 we have 2, right? Which is basically because of this show stack function. You can implement the same in C++ also. Just create a for loop that runs from I equals to top position. We are going to display all the elements from the top position. I is greater than equal to 0, which means that the stack is not empty, right? If the value of I will be equal to -1, then we are going to end this loop. Then the value of I is decremented by 1, and we are going to display it using system.out.println, right? So now in C++ also we can do the same. So now I'm going to just take this question, which is what is the difference in allocating the memory in runtime and compile time, right? It is a very important question. Even I have done a lot of research on I've searched a lot on difference between runtime and compile time, and in my C++ playlist, I think the first video was about runtime and compile time. I cleared it out at that time also. So there are two things, runtime and compile time. So let's say we have a program, let's say this is a C++ program, right, which has the extension .cpp. Now just focus here because this is a very important concept, right? So what we try to do is we have the CPU inside of our computer and we have the compiler, right? We have a C++ compiler. In case of Java, we have JVM as the compiler, right? Now, if it is a C++ file or if it is a Java file, the CPU cannot understand what you are writing in the C++ program, right? And similarly, it is the case with Java also. CPU understands only binary language, which is either 0 or 1. So we have to convert this C++ program into a binary form so that the CPU can run this program. For that, what the compiler does is we provide this file to the compiler or the JVM and it generates a binary file, right? It generates a binary file. In case of Java, it generates a Java bytecode, right? It generates a bytecode and this is then passed to the CPU so that the program can be run, right? So when we are passing the file to the compiler and it is generating the binary and the bytecode, when the compiler passes this binary or bytecode to the CPU, we call it as a runtime because at that time we are actually running the program, right? So let's say I have a C++ program where I have written int a equals to 2, right? Or even in Java they are same. So let's say I've written a equals to 2. When I pass this C++ program to the compiler, it will generate a binary and it will store it inside of the memory, right? It will store a equals to 2 inside of this binary file. It will store a equals to 2 inside this binary file. So it is at the compile time, right? Int a equals to 2 means a equals to 2 is stored inside the binary which is at the compile time, right? So now if there are functions in your C++ program and they want to access it, they can use the binary file. They can access it from here. In case of JVM, we have bytecode. It does the same thing. We pass it to the CPU, right? Now let's say we want we have at the compile time it is passed to the binary. The CPU, let's see how CPU runs the program, right? I'm working on the basics of this is the computer system architecture. Actually, if you know it, it will help you in understanding what these things are, right? So if the CPU wants to run a program, it access programs from the, right? What is main memory? It is RAM, right? It is RAM. Why it accesses RAM? Because it is a faster access, random access memory. So it will access it very fastly, right? Now you can see the compiler will compile this int a equals to 2 and it will store it in this binary form or the bytecode. Now the compiler will pass this binary or the bytecode, it will run it by pushing the code inside of this main memory, right? So inside of the main memory, these programs, basically these are instructions, right? I've studied microprocessor, so it helps me to understand it. Even you can understand it. It is very simple. So we have the binary code which is in the form of 0 and 1. We will push the compiler pushes these instructions in the RAM, and now the CPU can run the instructions and will display the result, right? So at the compile time, when the binary or the bytecode is generated, this a equals to 2 is actually stored inside of the binary and not the main RAM, right? Because at this time we are actually considering runtime, because now the CPU can directly access the instructions and run it, right? So instead of writing int a equals to 2, if I will write, for example, in Java we have the static keyword, right? If I write this word keyword static int equals to 1, similarly in C++ we use the preprocessor directive define, and we define some value. I'm taking the value that we have defined before, max equals to 1000, right? These are the same thing. Now what happen is when we are in runtime, right? When we write static int equals to 1, this whole variable a equals to 1, this whole variable a equals to 1 is not stored inside the binary. So where it is stored? It will be stored in the main memory only when the compiler pushes this binary into this RAM, right? If it will push the instructions, it will then allocate it inside the memory, right? So in the RAM, a equals to 1 will get stored at the runtime, right? Similarly, define max equals max 1000. There is no semicolon here. Max 1000 means we are going to allocate the value 1000 only when we are trying to run the program, right? Now if why are we using this? You can see when we are trying to define an array, let's say I define an array A with some elements in it, right? Let's say there are 50 elements inside of this array, right? Like this, let's say there are 50 elements inside of this array. At the compile time, these 50 objects, this array of 50, you can say integers or characters, whatever the data type of this array is, it is stored inside this binary or the bytecode. But if we will use max array, this is a very important line and the basic crux of whatever I have told you. The size of array is decided at the runtime, right? So when the CPU will, when the compiler will push the binary format to the CPU, right? At that time, the size of the array is decided because max will get stored here inside of it is decided, right? So for faster access, we use these static variables and define, and it is recommended. Then someone can ask why we are not always using this, why if it is faster access, why not to store all the variables inside the main memory? The reason is that the main memory has lesser memory space and a lot of programs are running in it. So it is recommended that we do not store uh, a lot of data inside of the main memory, right? So that's all for this tutorial. This In the next tutorial we are going to study about the linked list data structure, which is very, and that's all for this stream. We are ending this stream. If you have any questions related to this in the program, what you can do is you can ask it in the comments right now this stream. So I'm just waiting for you to ask if there are any questions. Right, so if you have any doubt, you can ask it in the chat. I'm just waiting. I will wait for one, then I will end this. What if we allocate the memory in compile time for max variable? All right, so here we have a very good question here. What will happen if we will store it in uh, here the question is, what if we allocate the memory in compile time for max variable instead of allocating in the runtime, right? So he's asking a very good question here, that here we are trying to, you can see here this is define max. Why we cannot do something like this? Just write 1000 here, right? Can we do this now? Basically, first let me see whether let me first run this C++ program, then only I will be able to answer your question. Okay, so I think I have to build it first, right? I will first build it, and here okay, so it is giving an error here. I don't know, I think I have some problem with this thing only. I will have to create a new launch. Okay, so let me just go to the browser and search for some online IDE. That way it will be very simple. Will the program hang? Right. Let me just open the IDE and we will just copy paste this one, right? So let's first switch to C++, right? Let's try to run this. I want to see whether it is running or not. All right, so it is running fine. So now you can see here, it is running fine. Now let's change this value of max to 1000, right? Instead of using the compile time, instead of using max 1000, right? Directly we will write 8000 and let's see what will happen. Right, so here instead of writing max, I will just change it to 1000, or let's take a small number, 10, right? Let's run this and let's see what is the error that we will get, or it will run or not. So you can see that it is running fine. To use 1000 here, just for check, I'm just writing this so that you can check it yourself also in your IDE, right? So you can see it will work fine without any error even if you use 1000, right? But I'm saying why to use max, because at we can decide the stack, right? Initially the stack was empty, right? The main reasoning why we are defining the size of the stack at the runtime is because we want to understand, right, the value of the stack or the structure of the stack is decided at the runtime. When we are running this program, we are trying to push the elements inside the stack. At that time we are deciding the this variable 1000, right? So it is basically for a faster access. If you will just write A50, it will automatically allocate everything inside the RAM, right? It will allocate 50 positions inside of the RAM. But if you will do it like this, it is going to only allocate when when the array is required, right? So the size of the array will be decided. Will the program hangs? No, the program will not hang. I've just shown you that it will run fine, but it is you can say an optimization, right? We do these very small optimizations a lot of times in our programs just to avoid overhead, right? If we will just allocate it, it will take a lot of compile time, which adds some time overhead. So I've already told you this define and using the static is basically it will store it in the main RAM and it reduces the time access, right? So these are the small optimizations. In competitive programming, we make these uh, you can see we use these define max and static variables because that reduces the compile time, and in competitive programming compile time is very important, right? So if you will study, I didn't understand your last explanation, right? I'm explaining you, the explanation is very simple. When we are defining it at the runtime, it will take the CPU less time to run this, right? It will take, the runtime will be reduced. So it is basically an optimization, right? There will be no problem if you write a 1000, right? If you will write a 1000, I've just shown you, it will, there will be no problem at all. But just for optimizations, we can use static or define, and it will reduce the runtime because runtime is very significant in competitive programming, right? about explaining in storage in RAM. Okay, so basically whenever you create a static variable or a preprocessor directive like this type of data is stored in the main RAM. The reason is because the main RAM, the CPU can access the main RAM very quickly, right? It is a faster access. I've already written here that it is a faster access, right? So the CPU can access the RAM faster. So for optimizations, these are used. They also have some different uses, and but basically for optimization we are using it. So when we write static in front of int a equals to 1, it is stored inside of the RAM. If it is if we will just write int I equals to 1, right? If we will just write this, it will not be stored inside the RAM, it will be stored inside of the binary or the byte code, right? And then it will be allocated inside of the RAM when this binary file is executed by the CPU, right? So that was the only crux. That was just an optimization to reduce a runtime. Why we are reducing the runtime? How we are reducing the runtime is by storing it inside the RAM. We will allocate them inside the RAM, and to do it we can use the static keyword or the defined processor directory, right? We can even store some functions. There are some functions that we can store. We can define static functions, and these functions also, I have a whole uh, tutorial on the static keyword in Java, in the Java playlist, right? In the Java playlist we have that, so you can check that out, static keyword. And if possible I will just add the link to this static keyword inside of the description of this video, right? So I think I will end this. So thanks to everyone for being here. Thanks to Mohammed Saddam Hussein for being here. I am really glad that you have come here. I hope that more people will come and they will also take the benefit of these live classes, right? In the next tutorial, we are going to discuss very important thing, which is linked list, right? It is the main concept. If you will miss this tutorial, basically the whole series will be a waste, because the binary trees and all the data structures that we are going to study in the future, like queues, binary trees, they all will have the basic idea of linked list, right? So thanks to everyone. Goodbye.